to conclude with these Pareto dominance relations, let us prove the following result. Suppose that for every h the individual weak preference relation is transitive. Then it is possible to demonstrate that the weak Pareto dominance is transitive as well. In other terms, also the weak Pareto dominance R inherits from the individual weak preference relation the property of transitivity. The theorem is in reality a simple one, but put attention to all steps of the demonstration. Take any three allocations. X, Y, and Z. I am using the symbols Y and Z, which we employed in order to denote production processes and the excess demand vectors to indicate allocations for sake of brevity. So clearly the meaning of these symbols Y and Z is different from the previous one. Let us suppose that Z, the allocation Z, weakly dominates the allocation Y. And that the allocation Y weakly dominates the allocation X. We must prove transitivity, in other terms, that all this result holds. The allocation Z weakly dominates the allocation X. Is it clear? This is our thesis. But what is the meaning of these weak dominances? Do you remember? For every h from 1 to large h, it must be that ZH is weakly preferred to YH, and second, YH is weakly preferred to XH. By definition, you obtain this result. But this judgment implies this result. Moreover, for at least one consumer, the converse judgment must not hold. But this is not important in this moment. We obtain this result. Since every weak preference relation is transitive, we obtain immediately that for every h, ZH is weakly preferred to XH. We obtain this result. In order to have that Z weakly dominate X for at least one consumer, the converse preference judgment must not be verified. Otherwise, you cannot assert that Z is weakly preferred to X. Is it clear? Let us suppose ab absurdo that this is not true. So, you have that for every h from 1 to large H, also the converse weak preference judgment holds. If these were true, it is not possible that Z weakly dominates X, because for at least one consumer, this result should be not verified according to our definition of weak dominance. Is it clear? Another step. Since for every subject XH is weakly preferred to ZH and ZH is weakly preferred to YH, you obtain that for every H from 1 to large H, XH, a transitivity of a weak preference relation, must be weakly preferred to YH. You obtain this final result. But this is impossible. Why? Because by assumption, the allocation Y weakly dominates the allocation X. This means that for every subject, YH must be weakly preferred to XH. But there is at least a subject for which the converse weak preference judgment does not hold. Here, however, the assertion is that for every subject, also the converse weak preference judgment is verified. Contradiction. And the contradiction arises from the fact that we supposed that substantial Z was not Z does not weakly dominate X. The theorem is concluded. Well, write and then I shall repeat all the proof. The theorem is analogous to the previous one concerning the strong Pareto dominance P. It is the following. If every individual weak preference RH is transitive, also the relation of weak Pareto dominance R is transitive. Take any three allocations like these, and suppose that Z is weakly dominates Y, Y weakly dominates X. You must prove that Z weakly dominates X. In other terms, for every subject, ZH must be weakly preferred to XH, and for at least one subject, it must be strongly preferred. However, from these, clearly you obtain that for every H, ZH is weakly preferred to YH, and YH is weakly preferred to XH. But since every weak preference relation is transitive, you obtain in the end that for every subject, ZH is weakly preferred to XH. Is it clear? In order to have this result, you must prove, on the contrary, that there exists at least one subject, say K, for which the converse weak preference judgment is not verified, and so you have a strong preference for that subject K. Suppose ab absurdo that for every subject, in reality, also the converse weak preference judgment is verified. For every H, XH is weakly preferred to ZH. But for every H, ZH is weakly preferred to YH. And so by transitivity of a single relation RH, you obtain that for every H, XH is weakly preferred to YH. But this is impossible, since by assumption the allocation Y weakly dominates the allocation X. This means for every subject is verified this weak preference judgment, and for at least one subject, the converse weak preference judgment is not verified, so that there is a strong preference judgment. But clearly this result is denied from our conclusion, and you obtain an absurdum, and therefore, evidently, the weak Pareto dominance R must be transitive. So, to conclude, weak Pareto dominance inherits transitivity from the individual weak preference relation, preferred and different to. And the other properties, well, if the set of allocation A is convex and every preference relation is convex and some other properties are verified, also the relation R is convex, but certainly other properties are not inherited by R. The relation R is a more complex notion than the relation P, which is more straightforwardly deduced from individual preferences. Is it clear? Well, these are the Pareto dominance relation. The next step, the most important one, is to define Pareto optimum.